Okay, good morning, everyone. Any questions before I start myself? All right, the first thing I would like to do today before I would take up all your, yes, I've read the problem number 13. Okay, before I start taking number 13 is a comment about the quiz. As you guys know, your quiz was graded and I put a, I post my comment right on the quiz. I hope you looked at them because it's important for you to know your mistakes. And the solution, I will put it out, once I finish this class. But I would like to make a comment because some of the problems are too important for some of you not to be able to do them. So the first question is absolutely crucial that each one of you can do it without any mistake or whatsoever. So it was, I gave you the function f of x equal x squared minus 2x, and I asked you to find and simplify the following expression. Okay. All right. So there were of course always, very good answers, but there were like a lot of students who could not get that. First, there is a tendency in the whole class, even though who got it correct, they switched from A to X. No, when I give you, I named the variable A, I want you to keep it A because we're not going to only use X as a variable. So I want you to have this flexibility of even if you have A, you keep it A. That's absolutely crucial. Second, okay, what is f of A plus H? So a lot of students broke it, like they took f of A plus H, and basically what they did was they did that. And this is absolutely not correct. I mean, this is really not correct. Like, let us say you have a following function. Suppose the function takes 1 to 3 and take 2 to 5 and take 3 to 15. That's really a function. Now, it doesn't have to take f of 1 plus 2. It's definitely not, you cannot split like this. Absolutely not that. F of 1 plus 2 is f of 3, which is 15. F of 1 plus f of 2 is 3 over 5. So you cannot split at all this way. So how do we do that? When we analyze what the function do, what does the function do? It takes an input, it's squared. So as I used to do, my input here is A plus H. It takes that input and it's squared minus 2 times the input. This piece here is the f of A plus H. It takes away from it what? F of A. What does f to do to anything you put in here? It's squared minus 2A. Okay, so and this is f of A. So please, everyone who got it wrong, make sure you don't do the mistakes again. Now the rest is algebra. A plus H squared, again, there were a very typical mistake going on. The quantity A plus H squared is not A squared plus H squared. Absolutely not. You cannot break this way. You just have to actually distribute. Or you remember that if you take A plus H squared and you distribute, when you distribute this, you get A squared plus 2H plus H squared. You do not get A squared plus H squared. So the last step is we take this term, and that's the term that, and then you distribute the minus, and then you distribute the minus again. And the rest is actually nothing left here. Those and those simplify, and you will be left with this term right there. Please, as I repeat, every student who got that wrong, make sure you can get it correctly. All right. In other questions you had difficulty with, even those who got this problem correct, got that problem wrong. which was number 3. Okay, and my question is, I gave you the function f of x equal x squared minus x, and I gave you g of x to be x plus 2, and my question was what? Was find f composed with g, watch carefully, evaluated at 2t. That's really what my question is. The mistake, let's see how we're going to do that. So actually, I'll come back to a new page. Let me stay here. Okay, how do we do this? Basically, what's the definition of the composition? You start with the input. That's my input. 2t is my input. You evaluate g at this input, and then f at g. Yeah. So let us begin. You start with 2t. You evaluate g at 2t, so that's the input of it, and then you take f of g of 2. A lot of students, what they did, and probably each one of you will recognize their mistakes, they basically did the following. They evaluated f composed with g and they multiplied it by 2t. That's absolutely not the case. 2t is the input for the composition. So you start 2t, you evaluate the inside function at it, then f of that. Now this being said, the rest should not be actually hard. It means that f of, what does g do to an input? It takes it, whatever it is, and add 2 to it. Then what does f do? It takes the input, whatever it is, square it, and then take the same input back. And the rest is a simplification. Okay, so those are very crucial mistakes. Please be careful with them. One more, the last problem, you guys did fine, so I will not talk about it. I usually address the problem that the class has difficulty with. There were some issues with the domain as well. So the domain was the following. It wasn't too bad, the domain, but I had to address some. Over x minus 4. Okay, so what is the domain here? Very good. What do we need? The minute you see square root, the function makes sense if the term under the square root of positive. So you definitely need to find, so we need basically to solve this. Okay, so that's the first thing. Then you have a denominator. And the only thing I need the denominator for it is to be different from 0. Some of you took the denominator positive. I don't need the denominator positive. I only need the denominator to be different from 0. There is no square root. So now this will give me x has to be greater than minus 3/2 if you solve it. And that's what made me f different from 4. Now with this in mind, my domain will be. So x different from 4 and x different from bigger or equal to minus 3/2. So we can either write it, this value of all values of x, such that this happened, and x different from 4. I accepted every student who wrote it this way. An interval notation, so at 4 you open it, and then there is the idea of union. Union means together with the interval from 4 to plus infinity. So this is the union sign, which means this interval. So basically in my mind, this is minus 3/2. So from minus 3/2 to 4, 4 not included, and then 4 to infinity. And this piece that we're actually removing from the domain. Okay, so this will take care basically of the quiz. Please, I will put the solution I urge you, for those who didn't do well, to go over it. That's the only way we will be moving forward in this course. All right, now I take Alex's questions and then we proceed. So Alex asked me about number 13 and let's see, number 13, I'm at section 1.2. Okay, all right, so, okay, I'm gonna see if I can put the picture. Oh yeah, not bad. All right, so this is number 13. And the question is, the graph of the function f and g in the figure are obtained by vertical and horizontal shift and scaling of the function y equal the absolute value. So this the black graph, that's the graph of y equal the absolute value. And the question is f. What is the formula for f? So to get the formula for f, I want to ask you the following question. How is f obtained from the absolute value? Once we answer this question, we can build the formula. So my questions to you is, and then I will take the picture. How is f, it means the red one, obtained from the absolute value function? Okay. Okay, who would like to tell me? How did I get f? What did I do? Vertical and horizontal shift. Any idea? It's a good question. Elizabeth, give me that in Word, right? Okay, I like the Word, and then I will go back. So what did we do? We took this one, we shifted to the right by 2. And then after we shifted by 2, what did we do? Shifted up by 3. That's what we did. Shift the absolute value by 2, and then up by 3. Okay, how does this work? Let us remember. Actually, I should probably put that. The transformation. If I have a function, any function, shifted to the right by 2, it means the new function, which is obtained from f by a shift to the right, is f of x minus c. And shifting up is f of x plus c. How will this translate in our scenario? The translate is that we start with the absolute value. That's my original. I'm going to shift it to the right. When I shift to the right, I get absolute x minus 2. But after I did that, we shifted upward by 3. So my function is this one. Absolute value. This will shift it to the right, and this will shift it up. All right, now the blue one. I give the whole class, let us say a minute, to give me exactly the blue one, all of you. I don't want one, I want a lot of you. Okay, so when I ask you questions, so write down how did you get it, and then do it, all right? I know that you guys have an answer, but I want all of you to be able to come up with that answer. Okay, I'm getting actually correct answers. So analyze it. I want you to analyze it for me. How did we get the blue graph from the black one? Okay, shift left by 2, agree. And then reflect across the x-axis, and then shift down by 1. Very good. So I will write it in Word. How do we do it? So first we're going to do the following. We're going to shift to the left by 2. We do that. And then we reflect across the x-axis. So I'm writing in Word everything you're telling me. And finally, shift down by 1 vertically. These are the way we get it. So we're taking this graph, we're shifting it this way, we're reflecting, which will give me that, and then we shift it down, which will give me the blue. So let us see in terms of function. So we're going to start with the absolute value. Shifted to the left, it means you add the 2. We're shifting to the left. So right now, I am doing this function, this one. That's the shift. And then I'm going to reflect. I reflect, it means minus the x plus 2. Sorry, minus the x plus 2. Right now, I am with this one. Now I want the blue. So the last step is I take the one I shifted, and then I'm going to shift it down by 1. And that's the function g of x. All right? All right, any questions about this? And I know that on my lab, I gave you some of problems along those lines. Okay. Anything else? Good. So this week, we're going to review the following problem, the following ideas. We're going to review the exponential function. We're going to review the logarithmic function, some of the basic function, and the inverse. And at the end of the week, we're going to review very quickly the trigonometric function. So that's really our plan for this week. Next week, we're going to start the notion of limits and continuity. All right, so today I'll start with the exponential function, and I will use it basically to remind you the law of exponent, because I will play in, the algebra of the exponent is important for us. So we are, I think, in section 1.3. And 1.3 will cover 3 things: the exponential, the inverse, and the logarithm. So today I do the exponential function. Okay. So what are the exponential function? Those are, so definitions, as we know what their form is. So the definition. So exponential function is function that has the following form. So exponential function. So the function that has the form the following form. F of x equal, so the input is x. The output is a certain number, b, to the power x. So they are called exponent basically because the input is based nothing more than the exponent right there, where b is a positive number, where b is positive number, positive constant. Usually it's called the base of the exponential. So a typical example of an exponential function. So a typical example, f of x equal, let us say, 2 to the x. Okay, so that's an exponential. The base is 2, and I can make up every possible number. A half to the x. The base here is a half. The base here is the number 2. Okay, so why do we need the base to be positive? Why do we need the base to be positive? Does anybody know why we need the base positive? Anybody have any idea why we put this restriction on the base? Okay, all right, let me tell you a reason why we put this restriction. Suppose f of x is minus 2 to the x. Which problem this would give me? negative exponent doesn't exist. I disagree. I will talk about that in a second. Why this doesn't make sense? It doesn't make sense for all values of x. So f of 2 makes sense because it's minus 2 squared. No problem, it's 4. It has difficulty at a half. Okay, what is f of a half? This is minus 2 to the power a half. But what's minus 2 to the power a half? It's the square root of minus 2, which is not defined or whatsoever. So negative exponent give me a lot of problems because they don't make sense at the half. They don't make sense at 1/4. That's why we restrict the base to be positive. Now, before we study those functions, I definitely have to review with you again the exponent. So here we are with the meaning of b to the x. Okay, so the meaning of exponent. I know a lot of you have seen this, but of b to the x. But I definitely want to review that. All right, so suppose n is a positive integer, n, nothing more than a positive integer. So okay, let us see. Very simple. Suppose what is b to the n? B to the n is nothing more than you take b, very simple thing, you multiply it by itself n times. So that's the basic definition. So if I put 8 to the 3, it means 8 times 8 times 8, as simple as that. Now, what does it mean? And this is I address negative exponent, I have to address it. What's b to the negative n? That's a negative exponent. This is equal to what? So when you have negative 1, negative 3, what does this exponent mean? Quickly, you can unmute yourself because so you can write it. Exactly, it's 1 over b to the n. So negative exponent, there is no problem with them. B to the minus n is 1 over b to the n. So if you write 8 to the minus 3, what does this mean? 1 over 8 to the 3. Okay, so quick review of the exponent. Now, rational exponent. What is b? It's not minus n to the power 1 over n. B to the half, b to the third, and so on and so forth. This is equal to what? Quickly. Anybody? It's the nth root of b. Okay, it means what's the nth root of b? It means the term that you raise it to the power n and it gives you b back. So quick example. What is minus 8 to the power a third? Remember, that's not negative, 1 over 3. It means the cubic root of minus 8. What's the cubic root of minus 8? It means what's the number? You take it to the power 3, you get minus 8. The cubic root of that is minus 2. Okay. Now, one more. What is b to the m over n? Okay. So this is what? Okay. N always is the root. It's the nth root and is the root of b. And now there's two ways you can see it. Either nth root of b, the whole thing to the power m, or these are absolutely equal, bm. So b to the m over n, this one is always the root, and this is the power. The one in the top is the power. So let us say quick example. Suppose I tell you, let's see. Okay. So for example, what's 8 to the power 2/3? Okay, without a calculator, who can give me the answer? With no calculator?
4.
I'm getting 4. Do I agree with them? That's the root 8 to the power 2. Okay, that's 4. All right, let's take another one. 81 to the 3/4. Again, don't use a calculator. I mean, I don't see you, but I trust you. Okay, give me the answer to that. 27, absolutely. This is the root, and this is to the 3. Now 81 is 3 to the power 4. So that's 3 to the power 3, which is 27. Okay, so very basic to actually remember. So negative power to that. So actually, let me give you one more before I go back. What's 27 to the minus a third? Again, without a calculator, please. One third, you agree with, yeah, a lot of giving me. So this is first a negative, mean 1 over 27 to the third. I'm not changing the fraction, it's the same, but then we brought down. So 1 over the cubic root of 27, it's 1/3. Okay, so very careful with those exponents. All right, now let's go back to the exponential function. Now that we a little bit reminded ourselves of the exponent, let's go back to the exponential function and graph them, because it's important to totally understand the graph of those functions. So I will do only 2 graphs and then I will generalize. So the graph of the exponential. Okay, so we start with, I will do only 2 as I said. F of x equal 2 to the x, and then we will do f of x equal a half, simple numbers. So, okay, now how each one looks like. Okay, to graph them, we will do the simple stuff. We can just take points just because that's the only way, x and 2 to the x. All right, I forgot to mention one thing here when I wrote those rules. Anything to the power 0 is 1. Okay, that's also important. Anything to the power 0 is 1. So now let us graph this a little bit very quickly. 0, 1, 2. I won't do more than that. Minus 1 and minus 2. All right, at 0, 2 to the 0 is 1. So at 0, my function takes the value 1. That's 2 to the x. Important. At 1, it's 2 to the 1, which is 2. At 2, it's 2 to the power 2, which is a 4. So at 1, it's 2. At 2, it's already 4, and it starts growing very fast. At 3, it's already at 8. So it's going to go that way for positive. Now, negative. 2 to the minus 1. It means a half. So right here at minus 1, it's a half. At minus 2, it's 2 to the minus 2. It's 1/4. It is 1/4 at minus 2. This is minus 1, minus 2. At minus 3, it's 2 to the minus 3. At minus 4, 2 to the minus 4. So it's going to keep going like that. So that's really the graph. Okay, now questions. Question. Can 2 to the x take a negative value? It means, can the output here be negative? Yes or no? No. No, absolutely no. Because even if the input is negative, even let us say the input is minus 100, the output is 2 to the minus 100. What's 2 to the minus 100? Is 1 over 2 to 100. So it's very small. It's never negative, and that's crucial. So first, the function never takes negative values. Now, another important thing. When x starts taking large negative value, what's happening to 2 to the x? What type of value is taking? Smaller and smaller value. If x is minus 100, the output is that, which is 0.1 I don't know, billions of zeros, very, very tiny. So when x takes very small value, sorry, large negative value, it means when x takes large negative value, large negative, 2 to the x takes very small value, very, very small value. Small value, okay, very small. So this line here, the x-axis, we usually call it, and probably a lot of you know that, we call it an asymptote, which reflects the fact that when x takes very large negative, the values are becoming very, very close to zero. So let us stop before we move to the other one. So what's the domain and what's the range of this function? What's the domain? All values of x. What's the range? What are the output values? All the positive number, definitely zero not included. So the range are zero, open at zero, because zero is not an output value. The output becomes very close to zero. It's never zero plus infinity, or all positive numbers if you want in one. So that's 2x. Now, how about a half to the x? What's really, how's the picture, and what's really the dividing things between them? So again, to draw this one, I will do it, you know, the way you did, the way you guys drew function back in middle school. I take bunch of input, bunch of output, and I connect dots. So again, I have a 0, I have a 1, I have a 2, and here I have a -1, and I have a -2. All right, at 0. I have anything to the power 0 is 1. I will not argue that. At 1, it's a half. At 2, it's a half square, which gives me 1/4. At 3, you saw the picture, is a half to the power 3, which is going to give me 1/8. So the numbers now are getting definitely smaller. Definitely at this stage, as x increases, the numbers are getting smaller, because if you realize from here to here, this is a half. This is a half square. So I'm actually multiplying by a half. So the number for x equal to 2 is a half the number for x equal to 1. From here to here, this is a half square. This is a half cube. It means I'm also multiplying by a half. So every time the output is half the one before it. So it's getting smaller. Half the time before it, it's getting smaller. It's getting smaller. So the graph will be like this for at least positive. At 0, it's 1. At 1, it's getting smaller. It's a half. At 2, it's actually a fourth. So the graph is going to be basically the opposite of the other one doing. It's going to go like that, at least for x positive. Now for x negative, what's happening? -1, that's a half to the -1. Now, if I use my exponent correctly, this is basically 1/2, because I have -1 here. 1/2, it means that's a 2. At -2, it's a half to the -2, which is, if you do the math, it gets 4. So here at -1, it is 2. At -2, it's 4. And the function will go like this. Okay. So again, as before, in this case, when x takes large positive value, the function takes very, very small value. So this line is again what we call the asymptote. So the line y equal to 0 is an asymptote. The range is always 0 plus infinity. Okay, so what caused this to be increasing? What caused this to be decreasing? Anybody have a good recollection? When is the exponential increasing and when it is decreasing? What really play a role in here? What's affecting the picture? Anybody? No, I don't see answers. I thought increasing when the base is larger than 1. Absolutely. It really have to do with the base. In this case, watch carefully. In this base, we're multiplying by 2. In here, we're multiplying by 2. So it's going to affect the whole problem is the base. If the base is, absolutely, if the base is bigger than 1, it means we're multiplying by a number larger than 1, it's going to be increasing. If the base less than 1, my function will be decreasing. So let us make this very clear. So in general, how is the graph? All right, so in general, and that's the rule. F of x equal b to the x. Okay, it really depends on the base. B strictly bigger than 1, B less than 1. And always positive. Remember, it's always positive. The base cannot be negative. All right, if b is strictly bigger than 1, okay, at 0, because b to the x, it's a 1. And this is going to be absolutely increasing function. If b between 0 and 1, this is what will cause it to be decreasing. And be very careful, it's always strictly positive. All right? So that's the general form or general shape of the exponential. It's really the base that actually determine everything. All right. Before we kind of shift those, because I want you to have a good feeling of how to shift, the number e. The number e will start to play a role in this course because it's a very important. I will just introduce it, and I know a lot of you are familiar with it because we have to know. So the number e is a number. It's not a variable, it's just a number. And we will see this semester why the number e is important in math. I mean, that what really. It's a number and it is like almost 2.718. It's a non-terminating decimal. Okay, and its importance basically for those who have an idea what the derivative is that the derivative of the exponential is itself. So that's what makes it very important. But let's not worry about that. Now let's just worry that that's an important number that we should know. So the exponential function, so this will bring up the following. When we talk about the exponential function, with base e is the function f of x equal e to the x. Now be very careful, always e is a number, that's not a variable. E a number, it's not doesn't vary, it's just a fixed number. So how is the graph of e to the x? So e is a number, it's bigger than 1, the base bigger than 1, so its graph is going to be like that. Okay, that's the x-axis and that's the 1. And that's the graph of f of x equal e to the x. Absolutely under control, total memory of this graph. Now, another graph that actually we should know how it is again e the minus x. How does this graph looks like? Okay, what's the base here? Can anybody tell me what the base is?
E.
Nope. Nope. Not E. Remember, the base should be b to the x. I don't have b to the x. 1 over e. The base is actually 1 over e, and let's say why Elizabeth told us it's 1 over e, because how can I rewrite that? I don't want to confuse you, but let's see, how can I rewrite this? I rewrite it 1 over e to the x. True or false? True or false? Anybody? Can I rewrite it like that? True, correct. Now, yeah, because what is anything to the power minus? Anything to the power minus. As I started by reminding you the negative exponent. It means 1 over b to the positive. That's crucial. So that's minus, I just brought it down. Now, this we could be written as 1 over e to the x. And the base now is the 1 over e and not the e. That's really what becoming the base. Anyway, so how the graph looks like? How the graph looks like? Okay. You can either use the fact that the base less than 1 is decreasing, or we can start taking values if you want, because this is such an important function that I want you to know this graph. So at 0, it's a 1. At 1 is e to the minus 1, which is 1 over e. At 2, e to the minus 2, which is 1 over e squared. The numbers are definitely getting smaller, and this is the graph of this function. Okay, so e to the minus x, it's decreasing, getting very, very close to 0. E to the x, the exponential function, it's increasing. When x takes large negative value, the functions get very, very close to 0. All right, now we're going to do one problem that requires shifting and all this kind of stuff. And then we remind you the law of exponent. So I would like you to do the following. If you have a piece of paper by your side, sketch the graph of, and tell me what do you think will happen to the asymptote, the new asymptote of f of x equal 4 minus e minus x. All right, so if you guys have a piece of paper next to you, just try to sketch it. It's simple actually. And I'll give you 2 minutes and then I will do it and see what's really happening. And give me basic, sketch the graph, and I want domain and range. Okay, I'll give you 2 minutes at most to do it. Get going, not more than 2 minutes. Okay, let's see. What would you do first? Quickly, please tell me on chat, what would you do first? So we're going to start with e minus x. What we're going to do first to get the graph? Morgan? Morgan Keane? Just your name is in front of me, so I'm picking on you. Anybody there? What would you do first? Graph the e minus x. Absolutely. So we start with that. After that, what do we do?
XY table.
What?
XY table.
No, we're not going to do that.
Shift it.
Right, we're going to start e minus x, then we're going to flip it, reflect it across the x-axis. Okay, so the idea here, I want you to use all the transformation we've learned to do that. Start with e minus x. So I write here, start with e minus x. Then absolutely reflect across the x-axis. And this gives minus e minus x. So step 1, start with this. Step 2, reflect across the x-axis. It will give me the minus e minus ex. So I'm going to reflect very close. Reflect, 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 reflect. That's my, and this is, if this is 1, this is minus 1. So this is the graph of minus e minus x. So this is e to the minus x. And that's minus e minus x. The last step is we're going to take this one and shift it up. Shift up by 4 units. If I shift it up by 4 units, I will get minus e minus x plus 4, which is the same as 4 minus e minus x. So we're not going to take points because that's not the idea for those problems. So now after I do this, I'm going to shift it up. So I will do the shift. Everything is going to be shifted. And let's be careful how we're going to shift it. So the minus 1, if I shift it, so I will have, this is shift 1 unit, 2 unit, 3, going to be shifted to here. Absolutely. All right. And now the minus e minus x, when x becomes large, the values are becoming close to 0. So what we're going to do is we're going to shift this axis 4 units, the x-axis. So I'm going to shift it and put it here. This is my 4, means I'm shifting this 4 unit because I want to shift the graph. So how's the graph now is going to look like? Minus e minus x, when x is large, is very close to the line, to the x-axis. So when I shift up, the values are going to become very close to this line, y equal to 4. So we're going to get very close here, very close, and then keep going. So that's really my graph. Okay, so we're going to shift everything. In the meantime, I have to shift basically the x-axis. I shifted 4 units. So this line now is the line y equal to 4. So what's the range of this function? Quick. What's the range? What are the output values? Minus infinity to 4, absolutely correct. So the output are minus infinity to 4. That's going to be the range of my function. All right, so we're just using those transformation. So once we know this one, is actually we can build on it and start graphing more interesting graph. All right. The last few minutes I have, I will remind you the law of exponent. Okay, what do I mean by the law of exponent? And all right, what's the law of exponent? Okay, I know you've seen them back in high school and in middle school, but we have absolutely to know them. So first, what do I mean by the law of exponent? I mean the following. If you have b is fixed, b is a base, b to the x times b to the y. A very simple one, okay? It's b, what do you do with the power? Quickly.
Add them.
You add them. If you ever forget what you do, what's b squared times b to the power 3? B squared, it means 2 b's. B cubed, 3 of them. So how many together I have? 2 from here, 3 from here, I have 5 of them. So if you ever really forget them. The other one is very different now. Quickly, to which power?
Multiply by them.
Multiply them. Very good. Now, bx over by. Again. Subtract them, x minus y. The last one is, if you have a times b to the power x, what does this give you? Oh, be careful. Yeah, it's a to the x times b to the x. Because, I mean, if you ever forget, just take number. What's if I take ab to the power 3, what do you get? It's ab times ab times ab. As simple as that. So how many a's? 3 of them. How many b's? 3 of them. So if you ever forget them, just give yourself very simple example. So my last question to you is the following. Very, very simple, because b times square root of b equal b. What's in the box? That's my question. Fairly simple. What's in the box? What else I want? All right. 1, 2, 3. Okay, the first one, what goes in the box? It's b multiplied. It's 3 halves, correct. It's b, the square root of b is b to the power a half. It means we add the power. 1 plus a half, b to the power 3 half. Okay, 2, quickly. Minus 3 half, because this is b to the power a half, b to the minus 2. It means b to the power a half minus 2, b to the minus 3 half. Okay. Quickly. The last one. Minus a half. Is she correct? Yes, she is. Because this is 1 over b to the power a half. B to the power a half is b to the minus a half. All right, the last one is ex squared. Put in the box. Is John correct? Absolutely. We're multiplying the power because this is nothing more than ex times ex. It means e to x plus x, which is 2x. All right, so that's a quick review of the exponential and the law of exponent. Now, for tomorrow, I will not give you a homework, 2 things about MyLab. Starting now, the MyLab homework will be graded. So it's not like the first week where I omit all the grade. Starting now, the grade will be taken into consideration. Having said that, for tomorrow, my homework is not from MyLab. I'm going to put this simple homework for you on Brightspace, on the homework sheet, and just download it and just do it. And we talk about it tomorrow. It's not due because I'm giving it to you, but please do it. It's fairly simple, but I will be testing you over also those type of homework. All right, so for tomorrow, it's just, I'm giving you a simple homework, and please upload it and do it. Okay, sorry, I will take 1 extra minute. Carlos would like to talk to you, or SI would like to talk to you. Carlos, can you please talk to them?
Hello, Carlos Reyes. I'm the one waving. Hello. So I have polled some of you, and so for our when we want to meet for our SI lessons, for SI study meetings, that's supplemental instruction. If you forgot. And so we will be holding them on Mondays and Wednesdays from 11 a.m. to about 11:50. That's about, because they're about 15 minutes. And so if you can, the first one is today. So if you can attend it, that'd be great. If not, then you can come Wednesday or next Wednesday because we have Labor Day next week, but or anytime. But I would appreciate it if you could make it today, just so we can get to know each other and stuff. More information will be on Brightspace. I posted a thing, so it'll tell you how to join the time. And so yeah, and if you can't make it any of those times, then feel free to book a tutoring appointment with me, and then I can help you individually, like one-on-one, about anything you need. And so, and if you have any more questions, you can email me, which you can find the email on the Brightspace as well. So.
Okay. All right. Any questions before we finish the meeting? Did you guys had enough time for the quiz?
Yes.
Yes.
Yeah.
Okay, great. So we keep it up the way.
Wait, so there's homework on
Yes, I'm
on
gonna put the
MathLab as
homework.
well.
What?
There's an assignment on MathLab.
Not for
MathLab.
tomorrow. Not for tomorrow, because my
Okay.
lab does not have the type of problems I want you to practice. All right,
Okay.
so I could not pick anything from my lab. They did not fit what I want. It's not there. So I'm giving you a homework for tomorrow. You upload it. It's gonna be, I will put it in once I close the class. You do it and we talk about it tomorrow. It's not due because it's not on my lab, but I think it is important. I want you to know how to do it. And I will be, as I said, checking you on it on Friday. All right. So for
Okay.
tomorrow, it's not on my lab because They don't have the type of problems I want. Is that
Okay.
clear?
So
And this will
yeah,
happen through the semester because sometimes I don't want the problems on my lab. I don't like all of them. So, you know, I will have the freedom to pick what I want. Does that make sense? And please,
yeah.
don't-
So when is that assignment that's on my lab? Like, what do I do with that? Is it due or anything or what?
up to now, all the my lab are not for grade. It's for you to practice. So the one I've assigned for today, I urge you to do it just to practice because number 13, you guys have to practice those. So you do it, but it will not be graded because that's what I told you last week. Starting this week, starting today, everything I assign on my lab will be for grade. Is that clear or I confused you?
No,
I have a
it
question.
makes
Okay.
sense.
Anything else?
I have one question.
Yeah.
So when you mean it's going to be graded, so is there really going to be anything different or just the fact that you're actually taking the grades into consideration now?
No, exactly. I will just take the grade into consideration now.
Okay.
Okay. So I will give you
All right.
enough time to do it. So I'm not like, I mean, I will give you enough time to do it because it's not, I want, okay, if you don't do it by tomorrow, as you guys realize, I'm letting you ask questions from them so you know how to do them and then you go back and do them. But they will be graded. Otherwise, you know, I cannot guarantee you guys do them. Pure and simple. Okay, anything else? All right, so class is dismissed. And for anybody who has personal questions, meet me on my office hours. Bye-bye for now.